Okay, our next speaker is Tom Cleary. Tom is the leader of the Engineering Fire Safety Group at the National Institute of Standards and Technology. He has a bachelor's and master's degree in chemical engineering from the University of Maryland and has worked as a research engineer in the Fire Research Division for the last 32 years. His research interests include smoke aerosol characterization, fire detection, and fire dynamics. He currently leads the Building Fire Safety Evaluation Project, which is focused on developing modeling tools to assess building fire safety, and the Smart Firefighting Project, which is focused on providing measurements and computational methods to improve firefighting safety and effectiveness. He is a member of several codes and standard committee, including UL 217, 268 standards on smoke alarms and smoke detection, and the NFPA 72 National Fire Alarms and Signaling Code. Our other speaker is Maria Marks. Maria has been active in the fire, life safety, and security industry for over 25 years. With a focus on the building design and construction industry, she promotes intelligent infrastructures to create safe, smart buildings and communities. As a member of Siemens Industries Affairs team, Maria represents NEMA on several NFPA 72 and 101 technical committees. She is a past president of the Maryland, DC, Virginia chapter of AFAA and the Junior League of Washington. Maria is the vice chair of the NEMA SB section and chair the section's Emerging Technology Committee. She's a member of the SFPE editorial board and the SFPE Foundation Board of Governors. Maria is also a member of the University of Maryland Department of Fire Protection Engineering Board of Visitors. A graduate of Wesley College, Maria holds NIST 4 and fire alarm and CFPS certifications. She resides in Kensington, Maryland, and when not working on life safety issues, can be found behind a camera lens or on the soccer pitch. I will now turn it over to our speakers to start their presentation. Thank you, Maria. Thank you, Tom. You now should have control.
All right. I'm looking. That's not it. Let me try again.
Challenge of saving files to very safe.
Yeah, I have a lot of windows open. Bear with me for 1 second. Somewhere there's PowerPoints. A PowerPoint. There it is. Right in front of me. Okay.
Great.
And presentation mode.
While we're doing this, wanted to just set the stage for some of you who may not have been a part of our emerging technology workshop this past spring. We started a conversation, or rather I should say we continued a conversation on how protecting lives and property, not only is it mission critical, but technology is changing the way we approach it. And what are the opportunities that we have so that we can give more information or targeted information to first responders to allow them to respond a little bit faster, a little bit smoother, and hopefully save lives and property. So if you want to go to the next slide, please. And this is where we started the conversation of what kind of data is available. How do we use it? Our environments and our buildings are so data rich. We're gathering all of this information on all these disparate systems. How do we get it to the first responders? We had a mix of fire, police, security, fire alarm as well, all part of the group in our emerging technology workshop. Afterwards, Tom reached back to Wendy and myself with the thought that he'd come up, and we just wanted to float this to the group and get a little bit more feedback. So I'm going to turn it over to you, Tom. And I would be remiss if I don't thank Denise and Andrew, because I stole their slides from the spring workshop. So.
Thanks, Marie. Yeah, on that spring workshop, I was excited because we were talking about, data, what's available, all with the thought of, wow, we can do a lot of great research. And NIST about, things like we're interested now, like AI and machine learning, and developing some of the tools and using fire models. But if we go back to that day, in the background of what I'm trying to present today was that Wendy mentioned, she commented that, after all this discussion, that we still don't routinely provide the fire alarm control unit information to the first responders. And that kind of hit home with me. And really, it wasn't like, it wasn't an aha moment, because I kind of knew that wasn't the fact. But, it kind of gave me a feeling like, we're thinking about doing all this great stuff, but we really need to think about, what can we do now to get information to the fire service? And then when we're building on the information and becomes richer, providing it as we go along. Like I said, we're currently researching using real-time data to make predictions. And you could think of those predictions happening in the cloud or wherever the data resides, but then ultimately getting this sort of predictive information to first responders, in terms of something that is will increase their situational awareness, or something that is perhaps actionable that they could respond to. But if we really look back at NIST, at least, the interest in using increasing amounts of information that buildings collect from sensors dates back at least to 1984, when Bud Nelson suggested that there was a wealth of information being collected that from building systems that could be useful to the fire service. And I give a reference there. And if nobody, some of y'all may not be familiar with Bud. Bud was a NIST employee at the time. He was a fellow of the SFPE, the Society of Fire Protection and Engineers, and in fact, he was a founding member in 1950, and so much so that there's the Harold E. Nelson Service Award that the SFPE gives out. So, he made this comment back then, and it sort of floated at NIST, and we were thinking about it, and then it came time that maybe there's some progress to be made. So, starting in about 2000s and up until the 2010s at NIST, research was conducted basically regarding procedures and maybe standards to provide the fire service with useful information from, fire protection systems and building systems. During those years, NIST interacted with NEMA, the fire service, various companies, and federal partners on a range of research activities. There was an effort to demonstrate tactical decision aid displays, where a group of NIST researchers partnered with the fire department in Wilson, North Carolina, to do some demonstrations. There was also work on a building information system and control system, BISICS, and that was documented in that decade. And then there are even more thoughts about how to transfer data to public safety networks, connecting buildings to these networks. And that's all sort of culminated with a last report that we had was titled Towards Smart Fire Panels, where you'll find basically all the references. It's a literature search and all the references up to that time. But then it kind of died away, and for various reasons, because people retire at NIST and some research activities change. I was here during all this. I wasn't actively involved, but I knew all the players who were working on this. I was mostly involved with smoke alarms and smoke detectors at the time in research. And then after, looking back and saying, okay, I see where NIST stopped, I just said, well, what's the latest thing I can find out there in published research? And very quick web search, I found 2019 document that was funded by Defense Research and Development in Canada from the University of Ottawa. And I read that report, and it heavily references the earlier NIST research. I mean, and specifically, I call out the report titled "Building Tactical Information Systems for Public Safety Officials in Intelligent Building Response," because the University of Ottawa's project partner, APX, a software development company, was working on something essentially titled the same name, the Building Tactical Information System, which says it provides solutions to first responders with all the necessary building information needed to effectively and efficiently respond to building emergency fire. So if you go to their website now, they don't have such a product. They have other products related, but actually no product that takes building data and presents it to the fire service. But there may be one-offs around or some small solutions apply, but there's nothing that's really universal. So that's where I thought there seems to be a need. Basically, we need to provide first responders with the relevant information on a more universal basis. There may be a jurisdiction that has a little bit, or they can gain access to some data or a little bit of data, but everything seems to be a one-off solution. So, it's one piece of software that interfaces in one way, and maybe that's it. But what I see now is the previous research direction and our current situation basically doesn't look to be in alignment with some optimized solution that leverages the current technologies available and is also flexible to accommodate new information and technologies and data analytics as they evolve. And just quickly, and I mean, I haven't spent a lot of time on it, but I just thought, looking at previous research and what I see as a need, and the bottleneck I see is there's a need for some standardized data formats and encoding rules to transfer data to the first responders, such that any app or web interface can process the data coming in and display it. And also to make sure that everything is more universal, if you have some standardization, you wouldn't allow proprietary non-standard data because that's not standardized transmissions, and that would maximize universality. And there's some various reasons for that. So you really want to keep control of that. And then clearly there's need for standardization of terminologies and text and symbols and graphical elements, and we'll talk about that a little later. And then there's also a need to establish some kind of accepted methodology to systemize data visualizations, specifically if there's going to be visualizing, sort of data analytics that, you can think of a million ways to do it, but it has to be something simple and easy, predictable, and scalable when the interfaces change. And then also there's the opportunity to relay audio and video information also. You have to consider that. So my thoughts were, how will we get there? Well, we probably need a standard. Now there's lots of talks of various standards in various parts, but I really don't see a standard that fits the needs that I believe the needs that I see. And that's what I'm trying to sort of flesh out people's ideas. But basically, ideally a standard. You could think of maybe you can start with a recommended practice, but ideally it'd be a standard. So what I did after I talked to Wendy in that meeting, I just said, well, what if I was to write out a scope? So I wrote a scope and I came up with a starting title for something called Building Emergency Situational Awareness Interface Standard. So that just gets away with saying that we're providing tactical information or this is a common alerting protocol, the CAPS. It's not, it's something different. And if you look at the scope, it's exactly the elements I had in the slide before on, the needs that I articulated. It's identical, it's just reworded. And then the standard basically would cover how the information is transmitted and then presented in this decision support role as it's being pushed or pulled. So thinking about that. So there's lots of things that could go to get to this point, but the standard would only focus on this. If we look at some examples of standards, at least for building equipment, you can think of the BACnet standard as an example here. So BACnet, if you don't know, it's a protocol optimized for brief object messaging on a LAN. But there are specific rules related to the needs of building automation and control equipment. So, You need to identify hardware devices. They need to identify the format of the data they're exchanging. But it's kind of simple, and it's set up for LAN. It uses a very, not a really rich encoding syntax, but it's completely acceptable to what BACnet needs. It took 8.5 years to develop BACnet from the start of the conception till its ending point, but it does have widespread adoption. But BACnet's not going to work here. But I'm just saying that they went through these processes and came up with something that had widespread adoption, and that's what I think is needed. Some of the considerations that I thought would need to be considered in a standard or would be the data types. Obviously, there's static, there's quasi-static data. You can think of static data as the building footprint. It's not going to get up and move. Quasi-static could be something else. There might be a convention going on, and a lot of activity in a hall where there's displays set up or something. There's also dynamic data actually from the building systems and the fire alarm systems. And then there's also predictive analytics. If you're going to pass this to the fire service, that you consider that as the data type. Obviously, you need to have standardization on the terminology, and that's quite obvious, but agreed upon nomenclature, and for everything, timestamps, objects, locations, actions, etc., and even forecasted outcomes. You have to have sort of a standardized nomenclature. And then there's the data structure. So the data structure basically would allow anybody developing an app or a process to read this, and you're not locking that down with proprietary data structures or non-standard data structures. And then the things I talked about, either standardizing some things or recommending some things in terms of the textual elements, the structures and things like that, and then symbolic and graphical elements. Preferably you want them all standardized. Now there are some standards, for instance, NFPA 170, the standard for fire safety and emergency symbols. You can draw on different standards. That standard alone by itself seems to be heavily focused on things like architectural drawings and where to use symbols on that. So you can think of this system where somebody might be viewing the data on a cell phone or a tablet, and they're not just looking at architectural plans. So there might be some needs for this different types of symbols to be standardized. And then some way to codify how you would present some data visualizations of the dynamic data and predictions so that they're easily consumable formats. And then for audio, there are many ways to do audio two-way communications, but if you're monitoring audio, you might just want to have a monitoring mode so you're not overloading somebody using this with too much and expecting responses on this. And then you might want to have voice to text, but that's pretty easy to implement. And then for video, maybe there's bandwidth issues there, but you can easily handle those. So also what I did is I just thought, well, let me think of a simple example. So what I did is I said, well, let's say I have a 10-story commercial building and there's a addressable fire alarm control unit there, and there's a fire in the building. And then I'm just looking at, okay, what kind of data would come out of this? Very simple case. It's mostly just a fire alarm control unit, not a lot of other things. But if you look at that dynamic data, the event logs coming out of the control unit, you have things like there's a fire alarm reported on one zone, and then there's an audible evacuation and visual signals activated on the floors above and below the fire floors. The central station would then be notified. The elevator, a lobby smoke alarm goes off. The elevators are recalled to the first floor and placed in a fire alarm service. There's a manual pull station pulled on the floor where the fire was reported. There are audible and visual evacuation signals activated in all zones. So the whole building is now going to be dumped. There's a duct smoke alarm. So there's some command sent to shut down fans and close smoke dampers. Then there's another smoke alarm reported on the floor above the fire. And then you get a water flow alarm. So that's good. So looks like sprinklers were activated. And then you also get a call button activated on the 7th floor area refuge. So you think of that as the data coming out of the fire alarm control unit. You also might have dynamic data, that'd be video. Let's just say this building has the building lobbies available and the exterior building entrances, basically exit points, have video. and they typically go to the building manager, but they might be available. And then there's audio monitoring, monitoring the two-way audio. So you have building elevator phones and the call intercom system. And then there's some other dynamic data I list here, and this is actually not from the fire alarm control unit, and this is not from the building itself, but there's a time when the first unit arrives, and that's a given particular time, and then there's a time when the entire full alarm, all the equipment is on site, and then of course there's static information that, and this is a simple case. We're not talking about complete architectural plans, but where's the power cut off? Oh, by the way, they put a photovoltaic system on the building roof, and you can't cut that off with the mains power supply. You got to cut it off somewhere else. Natural gas connections, and then the fire department connection locations, and then perhaps there's some forecasting or predictive analytics that are being run. Something maybe on egress, and maybe even something or temperature monitoring to suggest that the fire is in decay after the sprinkler goes off. So if you look at the previous example, all the fire alarm control data, basically a lot of things came in until the sprinkler came off. That was before the first unit arrived. So they wouldn't see this information until they arrived on and looked at the fire alarm panel. So they would get this earlier if they were able to get it. And of course, there are other information sources, and the slides that Maria showed in the beginning have a lot of different data sources, but just think about access control from the building, and then any building system actions that are not monitored by the fire alarm control unit. And as I mentioned earlier, the dynamic escape routing or emergency signage, dynamic emergency signage is different information. And then something that's not part of the building, but I just threw in there as a thought that, as there are firefighter location systems that can be used by the fire service now, and there may be other systems coming along, and maybe there would be a desire to overlay this type of information with the building information system also. But of course, the data basically is how you present the data is going to rely on the first responders' needs, and their input is critical. So early on, we have to really see what their input is. When this went down and worked with the Wilson Fire Department, some of the comments were that this is all great, but it's just too much information. They were showing floor plans and every alarm going off and things like that, and that's just not going to work. It can work at one level, but when you get down to a certain level, it's too much information. And also how the data would be used is going to be entirely up to the person with the authorized access. So this system is not going to control anything. If you want to do that, do it within the building. It's not going to be part of this, wouldn't be a part of this standard. That's a whole nother ball of wax. But the people using this would be authorized for access, and they'd have some specific guidance and training on what to do with the information. So I drew this picture just not because I like to draw, but because I just wanted to show you an example of topology, because that's an interesting word. But anyways, to show you, like, on the left-hand side, that's what I'm thinking, like, where I would see an implementation, an obvious implementation is the building is just generating some data and it's dumping it, into, let's just say, the cloud, whatever that is. It's some service, some provision for data storage. The protocol that we would develop here is not going to specify how that's done because it's not germane. You can do it any way you want it, in any way or method or means that you want to get to data somewhere. But then when you come back down and you want to provide information to the first responders, you could consider using FirstNet, which is sort of the dedicated wireless network for first responders around the country in the US. And that's good because that might have some benefits. And the standard will apply for everything here, these transmissions in blue. You could go to Emergency Operations Center, you go to the first responding unit, and a fireman who were holding a handheld device, outside the fire truck where maybe there's a tablet. You could have mutual aid response. That's another truck coming from the jurisdiction who might be using different apps for it, but the apps are standardized, so they'd be getting the same information. It might be presented a little differently, but you want to have this sort of universality here. That's one case. The other case would be maybe there is no cloud, and that you could use the standard in that application, but you'd have to have some sort of rules for how you would transmit this data to the devices, because it may not be a cellular. IoT there. It has to be some other solution, I would imagine. That's just the simplest case. We're not talking about physics, which would be discussing on how you're taking all the data in the building and the networks and all that stuff in the building. If you went that way, we're not talking about how you would transmit to the cloud. We're just saying like, okay, how do you get down to the first responder, and maybe a standard just related to that. Well, again, I just say here, wait, how does FirstNet fit in? I just threw that out there. And that's what I think is kind of interesting and exciting is that, FirstNet, it was paid for by selling the spectrum, and it's for first responders. And if you look at the authority, they they identified 6 domains to prioritize programs, resources, investments, and partnership activities. And if you look at the first 3 here, I ordered them this way: situational awareness, secure information exchange, and the user experience. That all kind of relates to what I'm talking about here. If we're talking about getting data to first responders for situational awareness, and these things are very important. Of course, the core means the network itself, and the coverage is the size of the network, and then voice communications. But there seems to be some, the FirstNet fits in this case. That's on their. They've identified that as priorities. And also the FirstNet has an app catalog that's a library of curated and dedicated apps that are dedicated to serving and supporting public safety professionals. So you could think of apps developed and to a certain standard related to situational awareness and building fire, would be important there. And maybe apps that would meet that standard could be submitted to the library. Well, when they're submitted to the catalog, FirstNet actually looks at each thing and evaluates it before it's approved for inclusion. So they vet it and verify it for security and reliability and its relevance to public safety. But they really can't do the relevance to public safety without pointing to like, oh, here's something that says it's relevant. And if there was a standard for this data transmission, it might help them do that. So that's something that might be very useful. So after thinking about this for a while, I thought, well, what can this do in the short term that maybe would be helpful? And we were planning to conduct some full-scale multi-room building fire experiments to demonstrate our ability to do some forecasting of primarily flashover and the situation in buildings and fires grow using heat detectors. That's what we've modeled with, and we've done a lot of research doing that and developed machine learning algorithms so we can get solutions very quick and very robust. So if we're going to do that and demonstrate that with some tailored data displays, well, we're also going to provide these predictions while the fire tests are going on to some wireless devices. And oh, by the way, we're going to provide the fire alarm control unit, which I'll have installed and monitoring various smoke and heat detectors, have it display that data in real time during these real fire tests, and also we'll display video data at the same time. So along with our predictive analytics, we're going to sort of display this other data to sort of show what can happen. But of course, this is one-off. There's no standard to follow, but we'll have to do this and come up with some rational thought of saying, here's what we did as our first cut. So the idea is to have this data displayed on handhelds or tablets, and then another display on a more extensive workstation web page-based application, and we'll be using local servers. And we may partner with others to test additional research objectives here and explore new technologies. So this plan, probably trying to get this in at least calendar year 2022 to do this. So this serves a couple purposes, but I also wanted to demonstrate this, and I just want to let you guys know that we're thinking about standards. We're also going to continue doing some research and showing here's something that could be interest. And lastly, I'll just leave with concluding thoughts is that the first responders really are entitled to this kind of information to improve situational awareness and their health and safety. I think they would really like to have it. They need to decide how to use it and how to how they want to present it to them and have input on that. But I think they would like to have this. but our ability to provide this information to emergency responders in a widely accepted manner is really lacking now, I see. And I think the development and adoption of standards facilitating that, it needs to be a priority. I mean, it's on our radar screen once again, and we're going to work on it a little bit. But I think as an industry, we talk about IoT and all this data stuff, but I really like to see a way to get data into the hands of the first responders, and it could be the simplest data, and we can build on it from there. And of course, whatever we're done needs to have flexibility and standards, because if we put all our eggs in one technology basket, it's not going to be very good. Or if we limit it and say new data sources or analytics can't fit in, that's not going to be good either. And then lastly, I think there needs to be some national organization to lead or facilitate the development of a consensus standard here. That national organization is not going to be NIST, because we don't have basically the ability to do that at this time, and we're not good at it anyways. That's why, I'm thinking maybe a NEMA or NFPA, a UL. I don't care. Somebody has to sort of kind of take a lead. It's just not going to organically happen. But NIST can help, and through work with this, and maybe possible to fund workshop or a fire grant to look in this part of this research. But hopefully it's not a 20-year activity, but it's maybe a shorter activity if possible. So with that, I'll stop the presentation. Be happy to take any questions.
All right, I will now stop the recording so we can start the Q&A. Thank you, Tom. Thank you, Mario.
Okay.